Right. The disk is rolling to the left as shown, and I want to try to figure out what the acceleration of point D is. So I'm going to write my relative acceleration equation as follows. Again, what I'm looking for is the acceleration of D, okay, relative to the acceleration of C, which I'll be able to find because I know it's rolling without slipping here. So that is alpha CD crossed with R of that'd be D with respect to C minus omega squared CD times R of D with respect to C. Now the main thing to recognize here is that I do need to know that angular velocity. So with a lot of these problems, we first need to find the angular velocity. Now, we have it given to us here, so we don't need to solve for it. But same approach, we're going to go step by step through these things. Again, at this point, I don't really know much about D at all. So that's what I'm solving for. I don't know its direction. I know it equals all these, so I'll go through each of these individually. So starting with the acceleration of C, okay, which again, because it's rolling without slipping, okay, this is going to be moving to the left, like so. So it's going to be negative the radius, 0.5, times alpha, which is 8, and that's going to be in the I direction, right? So that's going to equal negative 4 in the I direction. Okay, so that's the acceleration of point C. Okay, now I have the alpha cross R, right? So that's going to be alpha CD crossed R of D with respect to C. Now again, alpha is given to me. It's 8 and it's in the positive K direction, so it's going to be 8K crossed with R, and this is from C to D, so it's going to be up and to the right, so it's going to be positive in the X and Y direction. So it's going to be 0.5 cosine 45 in the I plus 0.5 sine 45 in the J. Now that cross product, when I do that, I get 2.83 in the J direction and negative 2.83 in the I direction. Okay. Now moving on to the last one, this is the angular velocity squared, and again there'll be a negative in front of that, so omega CD squared R of D with respect to C. So I'm going to put a negative out in front of that, and again now I know omega is 3, so it's going to be negative 3 squared, and again times that same R, which is 0.5 cosine 45 I plus 0.5 sine 45 J. Okay, so the same thing. I throw a negative in front of both of these though, and I get basically a negative 9 times each one of those, and I get negative 3.18 I minus 3.18 J. Now, alpha, or the acceleration of C, is just adding up all the I's, adding up all the J's. So I add up the I's, I get the 4, or I'm sorry, the negative 4, the 2.83, and the negative it's negative 4, negative 2.83, and negative 3.18, all of the I's, and that comes out to negative 10.01 in the I direction. Adding up my J's, I have the 2.83 and the negative 3.18, which gives me a negative 0.345 in the J direction. Of course, this is going to be meters per second squared, which is what the answer is. So you can see most of it is to the left, a little bit of it is down, right? So that acceleration at D is something in that direction given there.